let's continue with our series, and in this video we are going to see about t-test. So as we were discussing in the earlier videos, we'll use specific test in case of specific scenarios. So coming to the t-test or student's t-test or independent t-test. This test we use when we have to compare a dependent or a continuous variable with a categorical variable. As we were discussing earlier, when we were comparing categorical variable with a categorical variable, we were using test of association, that is chi-square test or Fisher's exact test. Now when we have to compare a continuous variable against a categorical variable, we will be using independent samples t-test. So let's see one scenario. Now for independent t-test or Mann-Whitney U-test, the scenario is the researcher wants to compare systolic blood pressure between participants with and without tobacco use. So here we can see tobacco use present or absent is grouping variable and systolic BP, which is a continuous variable. Okay, so now let's go to jamovi interface. First, before proceeding with any test, we should have a look of the data set, like which variables we are going to see. So tobacco use is our one variable which is categorical, which is correctly mentioned here. Now let's see, systolic BP has been wrongly labeled here as a categorical variable. We can see with the symbols. So now we can change this. We can change it to a continuous variable. Now we can see it is reflected here. Now in order to apply t-test, we'll first go to t-test and we'll click on independent samples t-test, because there are two independent groups, which is tobacco use present and tobacco use absent. So we'll drag the tobacco use to grouping variable and we'll drag systolic blood pressure to the dependent variable. Now it will give the p-value, t-statistic, degree of freedom, everything here. But this table is not enough for us to make interpretation. And again, henceforth or now onwards, whichever test we'll see, we'll have to do assumption checks. So there are two assumption checks which we'll normally do. First is normality testing. So again here the Shapiro-Wilk test, as we were discussing earlier, if the test is more than 0.919, which means it's significant, which means it's normally distributed. If it was less than 0.05, it would have been not normally distributed. Same in case of homogeneity. It is more than p 0.536, which means it is more than 0.05, which means it is we can say the groups are non-homogeneous. If the groups were homogeneous, then the p-value would have come to less than 0.05. So now at the stage of this assumption checks, if the normality test was violated, meaning if the data set was not normally distributed, we would have used Mann-Whitney U test. We can see the changes are reflected here. If again and again I'm repeating that if the data set was not normally distributed, we would have used Mann-Whitney U test. And if the assumption of homogeneity was not met, then we would have used Welch t-test. But in here, for our example, both the assumptions of homogeneity and normality are met, so we'll use student's t-test. Now we are saying for homogeneity because we are using two different groups, like tobacco use present and tobacco use absent. In the further videos, when we'll see about paired t-test, there we won't have an assumption of homogeneity because we'll have a single group which will always be homogeneous. So these are the few quite changes which we need here. Normality, again we can check with QQ plot as well. It is just loading, it will take another okay. So here again we can see that it is normally distributed. We can see the data points are scattered around this line. Okay, so it's up to you whether you use QQ plot or normality testing, but keep in mind that whenever we have a sample size of less than 50, we prefer this Shapiro-Wilk test, and when the sample size is more than 50, we prefer QQ plot. Now again for homogeneity, the test is Levin's test. So these are the few named tests, Levin's test and Shapiro-Wilk test, which have the p-value which works opposite to the normal p-values. where in normal case scenarios p-value of less than 0.05 is considered statistically significant. but here p-value of more than 0.05 is considered significant. Okay, but again, by this also it is not interpretable. Like, we now know that there is no statistically significant association between tobacco use and systolic BP as per this table, which is p-value 0.204. But again, we are not able to make an appropriate interpretation out of this. So in order to make an interpretation, we'll click on mean difference, effect size and descriptives. Now we can see in the descriptives, out of those who were not using tobacco, the mean of systolic BP is 131, and out of those who were using tobacco, the mean of systolic BP is 134. Okay, and the mean difference is minus 3.54. Now this minus has come because if you see, for our tobacco use, we must have to yes later, like the first is no, then is yes, but in no group the mean is 131 and in yes group the mean is 134. So this has subtracted 134 minus 131, so it has come minus 3.54. If it would have done opposite way, like if we would have grouped the variables like that, if you would have kept yes above and no below, then the difference would have come positive. But now let's assume that the mean difference is 3.54. The difference in standard error is 2.77 and Cohen's d, which effect size is minus 0.257. Now this whole table is an interpretable table. Now we can say that the mean difference in mean of systolic BP between the study participants who used tobacco and who did not use tobacco is minus 3.54 with a t statistic of minus 1.28 and is not statistically significant with a p-value of 0.204. This gives a complete interpretation of t-test or independent t-test, which is also known as student t-test. So let's revise our things. Like, first we'll use student t-test or independent t-test when we are comparing a continuous variable with an categorical variable. As in our case, the continuous variable was systolic BP and categorical variable was tobacco use. First we'll see for normality and we'll also check for homogeneity. We'll see if the assumptions are met. If the assumption for normality is not met, we'll use Mann-Whitney U-test. If assumption of homogeneity is not met, we'll use Welch t-test. In other case scenarios, we'll use student's t-test. And once we get an output, we'll click on mean difference, effect size and descriptives to get an interpretable result. Okay, thank you so much. Stay tuned for the next video where we'll be seeing the paired t-test. Thank you.